Let's be real, we're all kind of drowning in information. Books, articles, reports, you name it. And for an AI, trying to read and remember all of that is a massive challenge. But what if there was a way to shrink an entire library down to the size of a photo album? Well, a brand new approach is aiming to do exactly that by teaching AI a completely new trick for reading.
So let me just start with a question that sounds like it's straight out of science fiction. What if an AI could read an entire book, not word by word, but in a single glance? Well, believe it or not, researchers are getting shockingly close to making that a reality.
But before we get to that amazing solution, we really have to understand the problem. And for today's AI models, it is a big one. It's what's known as the long context challenge, and it's all about what happens when an AI tries to process something really, really long. So here's the deal. For an AI, short text is a piece of cake. It's fast, it's cheap to process, no problem. But the moment you start feeding it longer documents, think legal contracts, scientific papers, entire novels, the difficulty just skyrockets. It doesn't just get a little bit harder, it becomes exponentially slower and way more expensive. It's a massive computational nightmare. Now you might be thinking, hey, why not just have the AI look at an image of the document? And people have definitely tried that. But the current methods are, frankly, pretty clunky. They need these huge amounts of memory, and they generate way too many of these data points called vision tokens, which, ironically, slows the whole system down. It's just not an elegant or efficient solution for the real world. All right, so let's get to the really clever part, which takes an old saying and turns it into some seriously futuristic tech. We've all heard that a picture is worth 1,000 words. Well, some researchers at a company called DeepSeek-AI decided to take that idea literally and apply it to how an AI remembers things.
And they call this concept optical compression. The idea is actually simple, but it is so powerful. Instead of feeding an AI millions of words of raw text, you give it an image of that text. The visual format becomes this incredibly efficient way to compress and store all that information. It's like turning a massive text file into a single, compact JPEG.
Now, to really get why this works, we need to understand how an AI reads. It breaks text down into tiny little pieces called text tokens. A long document can have millions of them, but an AI can see an entire page of that same text using a much smaller number of vision tokens. It's really the difference between reading a book word by word by word versus just glancing at the whole page.
And the efficiency gain here is just staggering. We're talking about a potential 10-fold compression ratio. That means the AI only has to process 1/10 of the data to get the exact same information. This could completely change the game for the speed and cost of processing long documents.
So, the question is, how do you actually build something like this? Well, let's meet the hero of our story, a new model called DeepSeek-OCR. It was developed by DeepSeek-AI, and it was designed from the ground up specifically to prove that this whole optical compression idea can actually work in the real world.
So how does it pull this off? Well, the engine behind it is a thing called the DeepEncoder, and it follows this really clever three-step process. First, it scans the page at super high resolution to catch every single tiny detail. Then, it squeezes all that visual data down into a highly compressed summary. And finally, it processes that summary to understand the big picture, the context, and the meaning of the whole page. And you can tell this thing was built with some very specific goals in mind. It had to be able to handle those high-res images without breaking a sweat, use as little memory as possible, and, most importantly, generate a tiny number of vision tokens to get that incredible compression ratio we were talking about. Okay, an elegant idea is one thing, but the data is what really matters. Does this optical compressor actually work? Let's look at the proof, because this is where we see if the theory holds up when the rubber meets the road. And the results? They are really impressive. This chart shows the key trade-off, how much you compress the data versus how accurate the result is. Just look at that first bar. At a 10x compression ratio, that means the data was shrunk by 90%. The model could still reconstruct the original text with 97% precision. That is a fantastic result. But accuracy is only half the story. The absolute key takeaway here is that DeepSeek-OCR is also incredibly efficient. It's getting this top-tier, state-of-the-art performance while using fewer vision tokens than any of its rivals. In other words, it's both better and cheaper to run. This head-to-head test just makes it crystal clear. On a standard benchmark, a leading model used almost 7,000 vision tokens to process a page. DeepSeek-OCR? It did the same job, got a better score, and used under 800 tokens.
That is nearly a 90% reduction in the amount of work it has to do. That's not just an improvement. That's a whole different ballgame.
Okay, let's talk about the future, because this technology has implications that go way beyond just reading documents faster. What we're really talking about here is a fundamentally new way for AI to handle memory itself.
And this is where the research paper gets really fascinating. The authors suggest that this compression method could be used to simulate a very human-like ability, the ability to forget. A system where recent memories are sharp, but distant ones just naturally fade away over time.
Here's how it would work. Recent information, say from a conversation you just had with the AI, is stored as a high-resolution image. It's crystal clear. But as that memory gets older, the AI can progressively downsize the image, making it blurrier and using fewer and fewer tokens. The memory literally fades.
So, what are the huge takeaways here? Well, first, this is a potential path toward AIs with theoretically unlimited memory. It could make long, detailed conversations with an AI far more efficient. And it offers a new biologically inspired way to manage AI memory, preventing it from getting overloaded with useless information. It's a system that mimics how we remember and forget.
And this leaves us with one final, really provocative thought. We always think of memory as being the key to intelligence, but forgetting is just as important for us. So if an AI can learn to compress its past into a fading image, could it eventually learn to forget in a way that's truly recognizably human?